Hello, STEM Nation. Jeff here, and welcome to episode number 11 of STEM on Fire, where we interview practicing professionals in the area of science, technology, engineering, and math. Let's start by thanking our sponsor, Audible, who is offering a free audiobook. Just head over to STEMonFireBook.com. That's STEMonFireBook.com to get your free audiobook. Now let's get fired up today with our guest, Amanda, and I hope our chat will help ignite your passion towards a STEM career. Amanda Emrich holds a Bachelor of Science degree from Northern Illinois University in electrical engineering with an emphasis in biomedical, and works as an RF, which is a radio frequency engineer at GE Healthcare. Welcome to the show, Amanda. Fill in any gaps and share a bit of your personal life.
Hi, thanks for inviting me to come on the show. So just like he said, I went to Northern Illinois and got my degree in electrical engineering. I am currently at GE Healthcare. I've been there for 3.5 years. I actually started in the Edison program, which is a leadership development program. So I did that for 2 years. So I rotated through different jobs for 4 years and then realized I really enjoyed RF and then rolled off that program into my current position about 1.5 years ago. So I've been working in my current position on the MRI hardware transmit chain for about 1.5 years.
All right. Thanks, man. I appreciate the overview. So, Amanda, for someone not familiar with electrical engineering, and I think most are, and you've got an emphasis in biomedical engineering and also then focused on RF. Can you give some examples of career opportunities, and then we'll delve into your specific area of expertise?
Yeah, so electrical engineering is pretty broad, which is one of the reasons I went into the Edison program, because it gave me the opportunity to explore different areas of electrical engineering. Electrical engineering varies depending on what your interest is. So you can go into board design, so all of the different components that go into your computers or your phones or anything you can think of as electrical. So as an electrical engineer, you can actually design that. Some people go more the software route, so actually coding for the computer or, the software that needs to go into a particular piece of electronics. In my particular area that I kind of specialized in, I kind of went more of the RF route. And so that's more of working on antenna theory. So thinking of how can we transmit and receive signals. A lot of people think of cell phones, but in my particular area with the MRI, we're sending a signal into the body, and then the body then sends a signal back to the machine, and we read that. So that sending back and forth can be is considered an RF signal, and so an RF engineer would specialize on that. So a lot of just electronics in general for electrical engineers, also control systems. So that's kind of so for example, your car is moving forward, it recognizes something and then it feeds it back to the computer system, and that computer system decides if it's a good movement or bad movement. It's kind of like this feedback loop. That's a very simple example of like a control system. And then also amplifiers, creating your power that goes into any system that sends a signal, or just any system that needs power. A lot of times we start with a small signal and have to amplify it in order to get the amount of power that we actually need.
Okay, and did you have to take specific classes to get experience or to learn about RF, or is that something that you learned on the job?
It was a little of both, actually. So when I went to school, they encouraged you to specialize in an area, and I ended up specializing in antenna theory just because those classes kind of fit with my schedule, and I really enjoyed the professor. And so some of that information that I learned in those classes translated into my current job. A lot of it is also just on-the-job learning. A lot of the stuff I learned in college didn't really make sense until I got to my job, and now it's understanding it. It's that application. So I would say it's a little of both.
And so you chose electrical engineering, and you did an emphasis in biomedical. There's also engineers out there that go for biomedical engineering and then put a little bit of emphasis on electrical engineering. So can you explain why you chose electrical engineering and emphasized in biomedical?
Of course. So my school, the method that they did it was electrical engineering, and then you could emphasize in the biomedical. I felt like it personally gave me more options in that way. If I went in with a straight biomedical degree, I was kind of stuck in the biomedical field, as opposed to if I went electrical engineering with an emphasis in it, it allowed me to have a greater option for a career path. If I decided that I didn't really like the biomedical path or I couldn't find a job, particularly in the healthcare field or some type of biomedical field, I had a broader option in order to go in the electrical path. And it's also, if you're looking at the options between the two, they can go two very different routes. It kind of depends on what you want to do. If you want to do more of the exploration of drugs or just pharmaceuticals, that would be more of the biomedical route, as opposed to if you're looking to more of how different machines work in the biomedical field, I would encourage you to go the electrical path.
Okay. All right. Hey, that's great insights. I know we've interviewed some biomedical engineers that emphasized in electrical. And this is the perspective of going the electrical route with the perspective of biomedical. And Amanda, I'm going to circle back a little bit because you mentioned something about sending a signal into the body and then the body sends a signal back. And this is for an MR machine or a magnetic resonance machine. Can you explain a little bit how that works? How does a body actually send back a signal?
So when you go into the MRI, or as you said, the magnetic resonance machine, it's actually a huge magnet. So there's different strengths. There's 1.5T and there's 3T. So when you go in there, anything that's magnetic gets pulled, and your body, what actually happens is when you go in there, all of your atoms align into a line. And so then we send this RF energy into you, so that transmit of the signal gets sent into you, and it disrupts those atoms depending on what type of atom it is. If it's hydrogen versus oxygen, what type of tissue, if it's air versus muscle versus fat. All of those respond to this RF signal differently. And so if you have been in physics class, you'll be familiar with that. When you excite an atom, it responds. And then when it goes back to its resting state, it actually gives off energy. And so what's happening is we're sending this RF energy into the body. It's responding. And as the atoms are coming back to being aligned, they're giving off this signal, and we are then receiving this signal. We are able to post-process that signal, and based on some magic, we kind of joke and call it magic. It's just a lot of post-processing that happens. We are able to know what type of tissue that signal gave off, and based on that, we're able to create an image.
Yeah, there's a lot going on there for sure.
Mm-hmm.
So if I can just whittle that down, you're sending in, you have a big magnet, so you've got everything kind of aligned when the patient goes into an MRI,
Mm-hmm.
and then you inject some RF energy into the patient. You perturb the atoms a little bit, and then you shut off that RF energy, and then it gives that energy back off, right? Because there's the conservation of energy, and you look for that really, really small signal with your RF equipment, and then you convert that into an image and display it on a computer screen for a doctor to take a look at.
Correct.
All right. Hey, thanks, Amanda. Appreciate that. I know it's a complex machine, and hopefully if that interests you, STEM Nation, take a look at MR, take a look at RF. So, Amanda, you're an RF engineer. I assume you're going to meetings, you're doing designs. Could you describe what a typical workday might look like for you?
Yeah. So just like most jobs, you have the normal responding to emails, paperwork, kind of the non-exciting stuff. I feel like The non-exciting stuff, though, does help me learn my job. It's kind of learning the ins and outs of how the machine works and just how things process. But then the fun stuff is when I get to go into the RF lab and actually work with equipment. So in particular, in the last couple months, I've been working with a preamp. We were having an issue where we were getting noise into this preamp, and the preamp was amplifying it and causing image artifacts, just white dots on our pictures. And we don't want these white dots because it just ruins the image. A doctor can't look at this image and know if this person has cancer or whatever they're trying to diagnose because of these white images. They're artifacts that just hinder the image quality. And so I spent the last couple months trying to figure out what was going on. So I went into the bay, which is where we house our MRIs, did a lot of experimenting, took a lot of data, went into the RF lab, and again, took a lot of data. And it was a way to help me understand how the preamp and the system worked, but it also was, we were taking a lot of this data to try and get some baseline, trying to get an understanding of what was going on, how it was working. And based on all of this data, after about 3 months, we finally realized that the preamp was responding to some harmonics that were happening. So it was a long process, but we finally were able to understand what was going on. So a lot of my days were spent collecting data either in the bay or in the lab or discussing with people about the data I had taken.
Yeah, and STEM Nation, these are the type of problems that engineers face. You're not going to be able to Google and find the answer, and you're not going to find a lot of these answers in a couple of hours or a couple of minutes. They can take days, weeks, and even months. So you have to develop the skill to kind of basically stick to it and just keep plugging it away, plugging away, and eventually you'll figure out the reason for the issue, and the problem will be solved. And it's a lot of fun, and you get a lot of enjoyment, or at least I get a lot of enjoyment in solving those problems. Amanda, what is one thing that has you fired up about, I'll say, RF engineering and maybe the medical field in general, since you're in the GE Healthcare working on MR machines? So what has you really fired up today?
So the MR technology is actually relatively young if you compare it to X-ray or ultrasound. And so we are still trying to understand how much we can get from the MR machine. There's a lot of exploring still that we know we need to do. And so in that realm, I'm really excited to see what capabilities we can get out of the MR machine in relation to RF. How can we push those boundaries? How can we develop different amplifiers or just apply this kind of basic technology that we have? It's very complex. RF can be a little confusing at times. It'll be interesting and really cool to see how we push those boundaries and what different ways we continue to explore and really develop this MR technology. Every day I feel like I hear about a new algorithm that we've developed to create a better post-processing of our images to get our doctors and physicians better images. So that's just always really exciting to hear about as we are really pushing the boundary.
Yeah, I guess I didn't realize that about MR. It is fairly young. I think it's probably in the range of 20 to 25, maybe 30 years old at most?
Yeah, it's about 30 years, yeah.
Okay, thanks, Amanda.
Mm-hmm.
Hey, we're going to change gears here a bit, and we're going to move into an aha moment. Could you take us to a moment in time of an incredible aha moment you've had at work or your personal life, and tell us a story and how you turned that aha moment into success?
One of the main items of data that I take, or oftentimes RF engineers take, are what's called S parameters or scattering parameters. So we're injecting a signal into a device and we're letting the network analyzer, or this piece of equipment that gives us data back, we're sending the signal in and then receiving it back and looking at how this device responds to this signal we send in. And so in school, we talked a lot about how you calculate these S parameters, what they mean, how they relate to the equipment, what's a good value, what's a bad value, a lot of book knowledge. And when I got to my current job, I was doing a lot of these collecting of S parameters and just kind of taking them and not really thinking too much about what they meant until recently when I was working on that project I was talking about with the preamp. Again, I had to take a lot of data, which was often S parameters of various preamps. And as I'm taking them, I finally understood what they meant. It was it went from book knowledge to a head understanding, an application moment. I finally understood that, S21, when it's a gain. So how much is the preamp amplifying the signal? It really stuck when I was testing preamps that weren't working and they weren't giving me the right S parameters. So in this moment, it really helped me understand the preamps better, as well as I feel like it made me a more effective engineer, because now instead of just taking data and then looking at it later by myself or with another engineer, now I can sit there and actually take the data, look at it right away and understand, okay, this doesn't look right, either retake the data or do another method of trying to figure out what's going on with the preamp or what's going wrong with the device.
I will say that that's pretty common in college, right? You're going to learn a lot of theory and you're going to wonder, why am I learning all this theory? And you probably aren't going to understand how it applies in the real world, but just take Amanda's advice and, and my advice. And when you're in college, learn the material the best you can. And because when you do get out into industry and you start working, a lot of it is all going to get connected together and you're going to realize why you learned that in college.
Exactly.
All right. Hey, Amanda, we're going to change topics here a bit. And
okay.
If you could go back to when you're 18 years old, what would you tell yourself as you're heading off into college? Some things that you wish you knew back then or even knew back then that would help our STEMers launch into college successfully.
Don't be afraid to try new areas. I actually have a teaching degree and then taught for a couple years and then went back to school for engineering. And when I first went to school, I really enjoyed science and math and art, but I didn't know how to combine all of them except in teaching. And so I didn't explore different options of how to combine all of my passions or how to explore different passions. And so I would really encourage you to explore different areas or look into not the normal way of applying your passions or what you're good at. I would also encourage you to join organizations. So, for example, if you're an electrical engineer, join IEEE. If you are going into engineering and you're a woman, or just if you're going into engineering, you don't have to be a woman, I encourage you to join SWE or Society of Women Engineers. There's lots of engineering organizations out there, and they're there to help you out and to help you explore and meet other engineers in your like path. I would also encourage you to volunteer, especially at STEM events where you can really grow that or encourage that passion for STEM-related activities in kids and young adults. I would also encourage you to attend career fairs, even if you're not necessarily looking for an internship or a job. I would encourage you to go just to talk to people, to start getting used to talking to people about yourself, about your career path, and just to see what options are out there. And last, I would encourage you to attend conferences. Again, it's to get you out there to see what your options are, what other ways people have taken the path that you're considering and kind of traveled maybe a little differently. And again, a lot of times they have career fairs there too. And so it's another opportunity just to meet people in your field and to learn a lot in kind of a short period about new and upcoming things.
Excellent, Amanda. That's great advice. And I'm going to say that the theme in there is get involved with different activities, go out, meet people, talk to people. The field of engineering is so broad, and you just don't know what the capabilities all out there, what you could all go do as a profession. And as you talk to other people, your eyes are gonna get opened up to ideas that you never knew existed. And also that helps develop your network. And I'll say that one of the best ways to find a job, find an internship, is through networking, through somebody else. It's not just going to be applying through the website and just going to the career fairs. It's going to be from people that you know. So excellent advice, Amanda. I appreciate that. And if you could pick one or two skills or attributes that you think are needed for STEMers to be successful transitioning from college into their careers.
I would keep an open mind. As you are leaving college, you have a lot of book knowledge. And so we've emphasized this previously. You have this book knowledge and you're going into your career. A lot of times you haven't applied it yet. So just have an open mind as you're starting to kind of apply that book knowledge. Be willing to ask a lot of questions because you're not going to know it all. Even though you got that certificate, you don't necessarily know everything yet. Just ask a lot of questions.
Yeah, you have to keep an open mind, STEM Nation. And you've heard it before in the podcast if you've been listening. Do not be afraid to ask questions. The engineers that you're working with, the managers that you're working with, they're there to help you when you get launched in your careers. And they're willing to answer pretty much any question you have because they've got a lot more years of experience, and there's no way you can learn everything in college, and there's no way you're going to even know everything on the job. All right, Amanda, are you ready for the lightning round?
Yes.
All right. What is the best piece of advice you've ever received?
Investigate different areas of interest. My dad has always encouraged me to take things that I'm really interested in and explore it. Just read all about it just so that you can develop more of your passion.
And what's a personal habit that contributes to your success?
Asking lots of questions.
Asking lots of
Yes.
questions. All right. What's your favorite internet resource or phone app and why?
Microwave101.com. It's a great resource for understanding kind of at the basic level different topics. For example, I am currently working on my graduate studies. I'm working on my thesis, and I kind of ran across this new topic that I had never heard about before and went to Microwave 101, and they gave me a lot of information and then other resources to then go to for further information. So I would encourage you to check out microwave101.com.
What's one book you recommend and why?
I would recommend Microwave Engineering by David M. Pozar. It's the book that we went through for my antenna theory class, and it's actually a book that I'm using for my thesis. It's just a great resource to understand antenna theory and how RF works on a basic level, and then also getting a little deeper.
All right. So for your STEM Nation, if you're thinking about electrical engineering, thinking about RF, or not quite sure what RF is, go check out those links that Amanda's recommending and see if that interests you. And Amanda, as we wrap up here, can you share a parting piece of guidance for STEM Nation, and then we'll say goodbye.
Good luck to those as you explore. I really would like to encourage you to continue to explore different STEM fields. There are a lot of different opportunities, different avenues of exploration, different paths you can take. Make the most out of your time by trying new things. You never know, that new thing you might try might be the new career that you're going to love someday.
Thank you for that, Amanda, and we'll say goodbye.
Goodbye. Good luck.
All right, STEM Nation, I hope you enjoyed our discussion today with Amanda. Head on over to STEMonfire.com, subscribe to the email list to keep up with the latest happenings, and be sure to subscribe to the podcast on iTunes, Stitcher, or Google Play. Tune in next week where we talk with Greg, who is a mechanical engineer and also has an MBA. Until next time, I hope this chat has helped ignite your passion